This is our third example of the chain rule. This video assumes that you know the basic rules of derivatives on a previous video or out of the chapter 3 in your book. And we have the basics of the chain rule, so we're applying it now. F of g of x's derivative is the derivative of f, the outside function, with the inside function ignored, times g prime of x. So now we have p of x is the natural log of x cubed. So the inside function, g of x, is x cubed. The outside function is natural log. And as we quickly recall, the derivative of natural log of something, if we just had natural log of x, for example, is 1 over x. Okay, so the outside function is natural log. It's our f, and its derivative is 1 over x, or 1 over, in this case, g of x, which we're ignoring. So as we're finding p prime of x, the first step is to deal with the natural log, ignore this, and we get 1 over x cubed times the derivative of that thing we ignored, x cubed's derivative. And I always like to delay the second derivative here until the next step. So we've dealt with the f. We've taken f prime. Its derivative is, for natural log is 1 over the item, 1 over x cubed. We don't do the derivative here. We ignore g of x. So it's f prime of g of x, not g prime here, times g prime of x. So now we still need to do the derivative of x cubed, which of course from the power rule, the rule for x to the n, the derivative is nx to the n minus 1. So the 3 will come down in front and we'll subtract 1. So we'll put this on top of the fraction, 3x squared over x cubed. Derivative free, but we should of course simplify, and x squared over x cubed will cancel, giving me simply 3 over x. Now that is our answer, but I'm going to show that we could have done this without actually using the chain rule. From a simple rule of logarithms, you'll recall that the power goes out in front of the log. So 3 times the natural log of x, another way of writing p of x. And now when we take p's derivative, the derivative of natural log is simply 1 over x, and we get 3 over x. A slightly easier way. Wanted to use an example with the chain rule, but of course you can feel free to notice this power comes out in front and make the problem even easier by using a little bit of knowledge about logarithms before we attempt the derivative. Thank you for watching this video, and keep up your hard work on your homeworks.